All right, y'all. So 7.4, trigonometric identities. In the box says, two functions f and g are said to be identically equal if f of x equals g of x for every value of x for which both functions are defined. Such an equation is referred to as an identity. Okay, so an identity is when they are, an identity is when they are already equal. Okay, so, whoa, it's frozen. Give me 1 second. It's not responding. Come on, Microsoft Word. All right, there you go. So an identity is already, okay, an equation. That means they are equal to each other. So an equation that is not an identity is called a conditional equation. So we don't need to worry about conditional equation. We are going to be working with the identity. Now, chapter 6, which this is the review unit, unit 0 for you or from last year. As we know already, tangent is always going to be sine divided by cosine. Cotangent is the reciprocal of that, so it's going to be cosine divided by sine. Cosecant is the reciprocal of sine, secant is reciprocal of cosine, and cotangent, again, as mentioned, is reciprocal of tangent. So cotangent is the reciprocal of tangent. Now, these three right here are ultra important that you must memorize them by now if you didn't already from last year. So the first one was sine square. Let me write this out, and I'm going to show you how to get the other two very quickly, okay? So this is called the Pythagorean theorem for trig. If I take that one function, sine square plus cosine square equals 1, and divide each and every term by sine square, then that means I'm going to get 1 cosine square over sine square, as you know already, that's cotangent square of theta. And 1 over sine squared, that's a reciprocal function, so that's cosecant square. Oops, I'm missing a c. Cosecant square of theta. Now, that's how they came up with this right here. Mind you don't have to memorize a lot of things if you can just derive it yourself, okay? Now, what if I don't feel like dividing everything by sine square? Can I technically divide everything by cosine square? Sure. You're probably going to guess it, that it's going to give you the other identity that's sitting in that box. So divide everything by cosine square. There you go. Cosine square of theta, and cosine square of theta. So sine square over cosine square, as you know, that's going to give us tangent square of theta plus 1. That's a reciprocal function, so that's going to be secant square of theta. So that's going to give you right there. So if you can do the math quickly, you can get the other two Pythagorean theorem trig function pretty quickly. Now, we talked a little bit about odds and even identities, or odd and even functions, I should say, in unit 0, which is your review unit, okay? We talked about sine being an odd function. We talked about cosine being an even function. Tangent was an odd function. Cosecant is an odd function. Secant is an even function. And cotangent is an odd function. Okay, so as you can see, 4 are odds and 2 are even. And we talked about this a little bit too, and I'm just going to bring this up again. This is an even function because it's symmetric about the y-axis. This is a basic odd function, This is a basic odd function because it's symmetrical about the origin. So when I test it out, let's say I'm going to pick a positive value of x. It should equal to a negative value of x. So algebraically, we say, okay, f of negative x must be identical to f of positive x. So that's why you see all of the even functions, okay, as you can see here, this is even. All the even functions, which is this guy right here and this guy right here, when you have a negative angle, it's identical to a positive angle. Not so much on odd, right? So if this is an x, as you can see, this is negative x, and the outputs are not the same. But if I say f of negative x, which as you can see in this function, it should be -1 times f of positive x. Okay, what do I mean by that? So let's just use that function for a sake of simplicity. So what if x equals 2? Then if I'm testing this function right here, f of -2, which is really -2 to the third power, which is -8. Obviously, it's not going to be the same as f of 2, because 2 to the third is 8. But what if we go, okay, -1 times that? Okay, then now it's -8. So that's why this is true for all odd functions. So when it's an odd function for the degree, you can definitely, or the angle, then it's exactly the same as if we were to take -1 times the function of its positive angle, which is going to be super useful. So moving on here for the guidelines. Guidelines means, hey, these are just some hints. You don't have to follow it, but it's a good idea that you do. Guidelines for establishing identities. It is almost always preferable to start with the side containing the more complicated. Yep. Okay. Pick the side that looks scarier than the other. Now, rewrite sum or differences of quotients as a single quotient. What does that mean? If I have 1/2, take away 1/3, then they want you to rewrite it as single. That means over one common denominator. So find the common denominator and then match it up, okay? Sometimes writing one side in terms of sine and cosine functions will only help. So what that means is when you see tangent, cotangent, secant, cosecant, break it down in terms of sine and cosine, and not always, but it says sometimes. Always keep your goals in mind. As you manipulate one side of the expression, you must keep in mind the form of the expression on the other side. Now, don't lose track of what you are trying to prove, and do not, again, remember repeating, do not prove both sides at the same time, okay? Example 1, we will start the process of writing proofs with easy problems. A, simplify tangent of theta divided by secant of theta, and I'm giving you a hint here, by rewriting each trigonometric function in terms of sine and cosine. So in writing proofs, I always want you to write your steps down. And the reason is that some of you do your math horizontally, some of you do your math vertically, some of you just do it any space you have on your paper. So I can't really follow it. So if you number your steps, then at least I know where to go next. Now in here it says make sure you convert into sine and cosine. So tangent is going to be sine divided by cosine, okay? Then I'm going to write divided by this way, secant. Secant is the reciprocal of cosine, so there it is. Well, when you're dividing by fractions, you are going to change and flip, right? Change it to multiplication, flip it to cosine over 1. Then from here, we can definitely reduce. That allows us to simplify to sine of theta, and we're done. Now, when you're done, so I know that you guys are done, can you just put your initial on it? Angie Bloom, Lewis, I don't know, Lewis Clark, right? Whatever your last name and your first name is, just put your initials on there so I know you're done instead of being stuck. B, show that sine of theta divided by 1 plus cosine of theta equals to 1 minus cosine of theta divided by sine by multiplying the numerator and denominator by 1 minus cosine of theta. So again, write the question down. Since it's already on my paper, I'm not going to, but your step number 1 should always be the side that you pick to prove. Yes, you can change your mind, then you just have to do it again and put the new number 1 down. Okay, so it's to give you a hint, it says multiply both sides by, both numerator and denominator by the conjugate, which is 1 minus cosine of theta. 1 minus cosine of theta. Then step number 2, on the denominator, the conjugates, meaning that I don't really need to FOIL that out. I'm just going to multiply the first 2 terms and the last 2 terms, okay? Now, if you don't remember why we don't really need to FOIL, then you can FOIL it right now. So here we go. If 1 times 1 is 1, 1 times minus cosine is negative cosine, cosine times 1 is positive cosine, and then this one gives us a minus cosine square. So you can see when they're conjugates of each other, the middle two terms will always cancel out. Now on the numerator, I can technically distribute it, or I can leave it for now. It's up to us to decide. Then step number 3, as you can see, by the way, no, you may not cancel this and cancel that and thinking that in the bottom it's just now 1 minus cosine left. That would be ultra illegal. Okay, so cancel, don't do that. That's a big no, no, no. Now, keep in mind what we're trying to get to. We are trying to get to 1 minus cosine on the top. So obviously I want to keep 1 minus cosine on the top. I'm not going to try to get rid of it. But your identity says cosine square of theta plus sine square of theta always equals to 1. So what if I manipulate this and move, right? Move things around, such as move cosine over here. So sine square of theta equals 1 minus cosine square of theta. That allows me to substitute in the denominator to be sine square. So now just copy the numerator. Now we can cancel. There's 1 of that on the top, 2 of that on the bottom. I should have 1 left, right? So as you can see, my last step is to write the ending, which is 1 minus cosine of theta all over sine of theta. That matches the right side, and I'm going to write my initial, and I'm done with that proof. Now, what if I decided to pick the right side? Because for this particular question, both left or right are as equal difficulty level. So that means I'm trying to get this to look exactly like the left. Well, then that means I'm going to multiply the conjugate of the numerator. Okay. As you can see, these are hints that you can use. Then step number 2, do I have space to go vertical? Let me check. It's frozen for me again. Okay, I don't have enough space for vertical, so I'm just going to horizontal. So on the denominator, I will now leave the sine of theta times 1 plus cosine of theta. On the top, those two are conjugates. So as we spoke about this earlier, you only need to multiply the first 2 terms and the last 2 terms. Now step number 3, this is an identity, right? Just like that, except that you can move things around to create new different identities. So that I can take it out and substitute with sine square of theta. That will allow me, as you can see, oops, I forgot parentheses right there, to reduce. Okay, so by reduction, there's 1 left on the top. So last step, I'm going to write number 4, sine of theta all over 1 plus cosine of theta. Let's check to see if that's where we are. That's what the left side is, and it is. And write initial to tell me that you are done with your proof instead of I'm stuck. Let's see, how many more do we have left? Example 1, that is. I got 1C and 1D. Okay, just 2 more on example 1. 1C, simplify by rewriting the expression over a common denominator. Now this is the guidelines or the hint on number 2, if it's allowing you to see it at all once it's done freezing. Okay. Number 2 says rewrite sums or differences of quotient as a single quotient. So that's really what this is doing. So step number 1, copy down the problem again. 1 minus sine of u plus 1 over 1 plus sine of u. Your common denominator, you don't have a lot of choices here, so that both, you're just going to have to multiply those 2 together. So 1 minus sine of u. And again, you have to show me all of your steps. No, you can't do proofs in your head. The whole reason of doing proofs is that I'm trying to understand your head. I'm trying to get in your head. Okay. So as you can see, the first fractions I multiply by 1 plus sine of u. So what I multiply to the bottom I will now multiply to the top. Now the second fraction, I multiply by 1 minus sine of u. So that's what I am doing. Step number 3, we now have a common denominator, so we can put the numerator together. 1 minus and 1 plus, okay, sine of u. On the top, I have 1 plus sine of u plus 1 minus sine of u. From here, we can see if we can simplify a little bit. Bam and bam, okay? So that allows me to say, oh, wait, that's really 2. Oh, this is step number 4. Step number 4. On the denominator, I'm going to distribute those, and they happen to be conjugate. So it's 1 minus sine square of u. Step number 5, by now, 1 minus sine square of u is really cosine square of u. 2 divided by that. Step number 6, I'm out of space, maybe not. Step number 6, I'm going to go further. If you can, try to go all the way until you cannot have fractions anymore. So that's really 2 times 1 over cosine square of u. Step number 7, that's really 2 times 1 over cosine's reciprocal of secant square. And that is as simple as you can go. Initial, yeah, that means it's a success. Okay, last example in, last problem in example 1. Simplify by factoring. Yeah, I love factoring. So step number 1, copy the question down. 1 minus cosine square of v all over sine of v plus cosine of v times sine of v. Okay. Step number 2, on the numerator, it's a difference of 2 squares. So you can go 1 minus cosine of v, 1 plus cosine of v. Remember back in the day, it's like x squared minus y squared, or I can say x squared minus 9, and then you go, ooh, x plus 3 times x minus 3, same thing, right? So algebraically, that's, oops, I meant 3 again, this is y. Oh, it's frozen again, there you go. Like that. So same thing, when you see trig and the factoring rules are exactly the same still. On the denominator, they both have sine in common, so take out your sine of v. Then we have 1 plus cosine of v left. As you can see, those two factors are identical, so we can cancel. Next, we have 1 minus cosine of v divided by sine. We can go about this a couple different ways. Let me split it up to see if that's any simpler. What if I go, step number 4 that is, what if I go 1 over sine, oops, I forgot v, sine v, take away cosine v over sine v, okay? And then step number 5, 1 over sine of v is going to be cosecant of v, take away cosine divided by sine is going to be cotangent of v. So I think non-fraction format's probably a little bit better. So I'll go all the way to number 5. And yeah, that's example 1, just kind of basic hints. Until I see you next time.